Hello, this is going to be a short video tutorial on how to make a rolling mechanic for your game in Roblox Lua. So, first of all, we're going to put a local script because we want it to run on the client and take client inputs. And we're going to put it inside the character scripts because we're going to be acting on the character and it gives us an easy reference to the character to get its children, such as the humanoid root part. So we'll put a local script in. We'll give it a relevant name. I have an animation track, an animation, that I've already made that's a rolling animation. So I'll put that into replicated storage. And I'll quickly demonstrate that so that you can see the animation I've already got. Sorry. And it is this rolling animation I quickly made, and when you play it you'll see it's not great, but it's a good enough roll. So what you want to do is we're going to need the input service to get the user input for when the user is pressing the key to make the character roll. We want a roll key. So when they press the key, you're going to make the character roll. So input service, and we use input began for when something starts happening. And we get the input object and whether Roblox processed it. If Roblox did process it, for example, if they pressed the escape key, or if they were typing in a text box or clicking on a GUI, etc., GUI, then we don't want to do anything. So if input and not processed. So we're just catching any cases that we don't want to act on. Then if the user input type, which is a property of an input object, and if it's keyboard input, then input dot keycode is our keycode that we want to roll on, then we'll start doing our roll. I'm not going to put the code for starting roll into a function because this is the only place where I'm going to call it from, so there's no need. So we want to know the time that we started a roll out, and I'll set it to 0 so that we don't have it acting on the character when they join the game and testing. So what the plan is in run service is we'll connect to heartbeat, which is when the physics happens, and we will do based on the time since the last heartbeat is we'll move the character if they're supposed to be rolling. So we're also going to need to get the humanoid root part to apply the C-frame onto it. So we're going to move the root part by a C-frame, which will move the character. So what we'll do is we'll do script.parent, which is going to be the character when this runs, because it'll become a child of the character when the character loads, and then it's a descendant of the player, so the local script will run. So we can do simply script.parent wait for child humanoid root part. And to load and play our animation, we'll need the humanoid as well. So we'll just do the same thing. And then we'll do our roll animation is humanoid load equals game.replicated-storage.roll animation. That should be reliable behavior. And our roll track, which is going to be the animation track, is humanoid load animation. And this loads the animation, gives us an animation track which has dot length and the play method, so you can play the animation, etc. Since the client replicates to the server for characters, or at least as of sort of when I'm making this video, then playing the animation on my client will replicate to other clients, but we can verify that in testing. So I want the roll distance to be 15 studs, so we're going to get a roll multiplier, which you'll see the use of later. And it's going to be roll distance over roll track dot length. So heartbeat does give us the elapsed time for the client when in a local script, but I'm gonna use tick anyway. So equals tick minus last beat, and I'm using tick instead of 0 for the defaults, so that I don't get some huge value. Like, you give me some unexpected behaviors if you start a roll immediately after spawning. I mean, it's really, really unlikely, but still, you know, something to consider. And what we want to do is, if the time since the roll started, so when you press the key, roll start time equals tick. So the roll starts when you press the input button, and we want a roll direction, which is going to be a vector. So roll direction it is the camera of the client, and we get the C-frame look vector, which is the a unit vector that is the direction the camera is looking in, and we'll get rid of the vertical component so that it's just doing on a flat plane, and then we'll let Roblox handle the sort of physics of falling or going up and down based on slope, because the humanoid code, the sort of boilerplated, handles all that for you. So we do roll track dot length, and also we'll do repeat wait until roll track dot length is greater than 0. We need to do this because when you load an animation track, it's asynchronous, so the length doesn't immediately load in. So when we use it here, if we don't wait for it to load in fully, which will then set the length as well, if we don't wait for it to load in fully, then we're going to have division by 0, which gives us an infinite roll multiplier. So we teleport off into space when we apply that. So if we are meant to be rolling, then we simply do that the local roll vector is the roll direction times, and we'll just make that an empty vector to be clear on what the type is going to be the roll direction multiplied by dt, and then multiplied by the roll multiplier. So this is just going to be a default distance of 1 for the roll, and then we times it by dt, so that if 0.2 seconds has passed since the last update, then it only does 0.2 studs of a roll, so that in 1 second it does the roll amount. And then the roll multiplier is going to constrain it to the animation length and also give us the correct rolling distance. So then we just do that the humanoid root part dot C-frame is, and we're going to make it move in world space, the roll vector times our existing C-frame for the humanoid root part, and we'll also play our animation here, and that should be it. So we'll do a quick client-side test or local test, and then we'll do a full test. Oh wow, that's way more than I was expecting. That's because I haven't stored last beat. So because I'm subtracting last beat, it needs to be updated for each tick. So at the moment I was just doing the tick minus when the character loads, but now it'll be when the last heartbeat was. So it should actually be 0.2 this time. There we go. Our character rolls in the direction. Well, near enough. Is it meant to be the commutative? That should be the world space one, right? Forwards. Yes, and then I just need to... Sorry about that. No, it should be the other way around. Yeah. So that goes in the direction I'm looking. Because it's right to left. Yes. And then... Now what do we have? So yeah, local test, and it rolls. We want the character to rotate to face the direction of the camera. So what we want to do is we want to do humanoid root part.cframe equals cframe.new humanoid root part.position, and then if we give it a second vector 3, then it will be a cframe at the first vector facing towards the second vector, so we can do dot position plus roll direction. So now it will face in the direction it's rolling. So when we test this, rolls forwards, snaps to face the direction the camera's going in. And then, we want to stop someone from constantly clicking it, so we can do and tick minus roll start time is greater than roll track dot length, which basically means if the character isn't already rolling, so if the animation's not playing, which is not necessarily... This is a bit faster because rather than calling it is playing, we are just going to calculate it in line with this left function call. And this is because roll start time is set every time a roll starts, so there's no other way of a player causing a roll. So they should have reliable behaviors. And then we just need to check that it replicates properly to other clients. The movement's handled on the client and the rolling animation on the client, so it should be synced up nicely. And I'll just test it with 2 windows to be able to see. Loading times. Okay. So on this screen I'll just get that player at the edge, and then I'll just press the Q key. Lovely. Cool, okay. Works. And that is how you make a rolling animation. So, some comments on good practice is that you should comment your code. So, this is quite clear, don't really need to comment that. It's clear this is a service we're going to be using. This one is worth commenting, so wait for the animation to load in fully before continuing the script execution. These are all the variables we'll use for tracking roll data, and then we say when the user presses the roll key, make them roll. So that just describes what this block of code does in general, and then more specifically roll in the horizontal camera facing direction, and we want to make the character face the direction they are rolling in. In terms of this, when the physics updates apply the roll movement, dt is the time since the last physics update. I think heartbeat is the physics update, it should be. And we will... you could just put a massive for loop in there and check that with the micro profiler, but I'm not going to. And then... yeah, that's basically, yeah. If the character is rolling, then move the character based on roll distance, roll speed. So distance over time gives you velocity, and we're taking our our unit velocity vector and multiplying it by the speed, so it's at the right velocity for moving 15 studs. So yeah, that is what 10-minute or so tutorial on how to make a rolling mechanic in Roblox Lua.